Welcome to 1.4, example 1, where we start to actually look at the inverse itself. So one of the things I'm going to do just to make this a little bit easier with the language is I just do want to identify that the function they've given to us is f of x. And the only reason why I want to do that is because knowing how to go from f of x to the inverse of f of x makes this so much easier. And if we picture this as a mapping, then the way that we go from f of x to the inverse of f of x is that any point x comma y becomes y comma x. Now, I'm not saying that the y coordinate is the one listed first. I'm saying that a point at, let's say, let's grab one, 6 comma 0 is going to turn into 0 comma 6. And I think if we grab the points off the graph and what I would call the key points and picking those kind of one by one, we have negative 6 comma 4, we have negative 4 comma 6, 0 comma 6, 2 comma 2, which will be a very important point, 4 comma 2, and then the last one there is 6 comma 0. If I transform those points, negative 6 comma 4 becomes 4 comma negative 6. Negative 4 comma 6 becomes 6 comma negative 4. 0 comma 6 becomes 6 comma 0. 2 comma 2 stays as 2 comma 2. And 4 comma 2 turns into 2 comma 4, and then last 6 at 6 comma 0, struggling a bit here, turns into 0 comma 6. Now, all I've done there is I've switched the x and the y's, but I would like to make this point, pun intended, that is an invariant point. And then just to reiterate what I'm sure I touched on in the instructional lessons, these invariant points occur when x is equal to y. Anywhere that x is equal to y, and that's that visual aid that this is a reflection across the y equals x line, and we'll look at that on the graph in a second. But what I'm going to do in red is I'm going to take those 7 points that is generated, and I'm going to put them onto my Cartesian plane. That's actually 6 points, sorry. So 4 comma 6 is right here, 4 comma negative 6. Oh, they really don't do us a favor with this particular graph. That means I have another one. I'm just going to pull it up here and put it into position. All right, it might be a little jarring that it just kind of magically appeared, but really importantly, that graph does show us in red, which is convenient, the points that we just transformed. So just kind of ticking them off one by one. 4 comma negative 6 is here. That's connected to 6 comma negative 4, which is connected to 6 comma 0. There's my invariant point. Then we have 2 comma 4 and 0 comma 6. Now, they drew in that green line, which is just such an important visual to see that that inverse function is a reflection of the original function over what we call the y equals x axis, which isn't something we've dealt with a lot or maybe at all at this point, but it is an important kind of characteristic because an inverse can be, maybe approached or understood as a reflection, which we have certainly done a fair amount up to this point. And I think it is a pretty big benefit of seeing that relationship. Okay, the next wants us to state the domain and range of the relation and its inverse, the relation being the graph in blue and then the inverse being in red. And we're just going to exploit that graph, and we can take a look at the domains and ranges as given to us. So again, I'm going to just label this as f of x and the inverse of f of x. And looking at that domain and range, my original function, x exists, and I'm going to use interval notation to kind of get, well, let's do inequalities for this. So x is greater than or equal to negative 6, but less than or equal to positive 6. And for my range, y is greater than or equal to 0, but less than or equal to positive 6. All right, and then of course in both of these cases, x and y are elements of the real. They can be any real number within those inequalities. When I look at my inverse, let's do the domain first. So on that red graph, or red relation I should say, the smallest x value I've highlighted in red there, and the largest x value I've indicated in red there. That interval is that x is greater than or equal to 0 and less than or equal to 6. And again, x is an element of the real. For the range, though, I now have that y is greater than or equal to negative 6 and less than or equal to positive 6. And y is an element for the real. And what we try to highlight by writing this out and saying it really, really explicitly is that the domain and range have switched. And if you think about that inverse as x becomes the y and y becomes the x, it makes a lot of sense that they would switch. Because basically all of our x values are now y values. So all of those x values that were greater than negative 6 but less than positive 6 are now y values. So the domain, and I don't like writing these arrows, but I'm going to write it. The domain of my original function became the range of my inverse. And the range of my original function became the domain of my inverse. And that's something that we're going to see very, very consistently. And it's really, really important that we remember that this is really all that's happening in these situations. Now, because we have the graph, it's actually pretty convenient for us to determine if they are functions or not. And with the graph of both, I would recommend the vertical line test. If you only have the graph of the original, then you can use the horizontal line test that I talked about in the instructional video as well. So using my vertical line test, and this is the wonderful thing about the smartboard, is if I draw a nice big vertical line, I can now move that around on my function. And looking at the blue graph, it only touches the blue graph in one location. So f of x is a function. I'm going to write that above here. F of x is a function. When we look at the inverse, though, that's f negative 1 of x. Let's do our vertical line test as well. So this line in black that I'm dragging around here, looking at the red graph, we run into a bit of trouble in this section. And I'll leave it there because I know there's a bit of a delay. And this section. Both of those are vertical line segments. Vertical line segments are giving us multiple outputs per one input. And that's really the definition or the difference between a function and a relation. So f of x, I'm just going to put is not the inverse of f of x is not a function. And I would recommend, because you've watched the instructional video like such diligent students, that you try to confirm that by using the horizontal line test on f of x as well. All right, that's example 1. 2 more to come.